So what if I told you the secret to building smarter AI isn't about teaching it more, but actually teaching it less? Today, we're diving into a pretty radical new idea that completely flips AI training on its head. It suggests that the real key to intelligence is knowing what to ignore.
It sounds kind of backward, right? For so long, the whole game has been to make AI perfectly mirror human answers. But what if that obsession with perfection is actually a cage? What if it's limiting what these models can truly achieve by making them, well, brittle and focused on all the wrong things?
All right, so to really get why perfect can be the enemy of good in AI, we need to pull back the curtain on how these models are usually taught. It all starts with a process called supervised fine-tuning, or SFT for short. And believe me, this is where the trouble begins. Imagine a teacher who doesn't care if you actually understand a poem. All they care about is that you recite it exactly, word for word, just like they did. That's basically SFT. The model gets shown one perfect answer, and it's punished for any little deviation, token by token. See, it's not learning to reason, it's just learning to parrot. And this is exactly where that super rigid method hits a brick wall, because that's just not how language works, is it? We all know there are a million different ways to say the exact same thing. Language is messy, it's creative, and it's wonderfully flexible. Just take a look at this. All these answers on the right mean the exact same thing, 42. But to a standard SFT model, nope. They're all wrong simply because they don't perfectly match the one correct answer it was given. This forces the model to obsess over the style of an answer, not the actual substance. And researchers have a name for this: surface-level overfitting. Okay, so the obvious next step is to just show it more examples, right? Makes sense. Well, it turns out that's pretty much a dead end. Not only is it unbelievably expensive to gather all those different perfect answers, but it can actually backfire. It can confuse the model with all these conflicting styles, and sometimes it can even make it dumber. So if perfection is the problem, and just throwing more examples at it doesn't help, where do we go from here? Well, the breakthrough came from a really surprising place: the AI itself. It turns out the AI holds the key to solving this puzzle, hiding a clue about what's important and what's just noise. This right here, this is the core idea from the research paper. And it's a fascinating hypothesis that there's a direct link between how confident the AI is about a word and how important that word actually is to the meaning of the sentence. Let me break that down for you. When the model is really confident about the next word it generates, that word is almost always crucial to the logic. Think about a sentence like, "The capital of France is Paris." The words capital, France, and Paris are going to be high-confidence core logic, but you could also say, "The capital of France is, of course, Paris." That little "of course" is low-confidence stylistic flair. It doesn't change the meaning one bit. And guess what? The data backs this up beautifully. Researchers sorted words into core for meaning and trivial for style. And just look at the difference in the model's confidence. Core words have a really high average probability, while trivial words, they're much lower. The AI is practically telling us, hey, this part is important, but this other part, yeah, that's just decoration. And just so we're clear, this isn't a small difference we're talking about. The statistical probability of this happening by chance is practically zero. So this connection between the AI's confidence and a word's importance, it's real. So the big question is, how can we actually use this? This discovery is the key that unlocks a much smarter way to train AI. The researchers developed a whole new method based on this insight, and they call it ProFit, which stands for Probability-Guided Fine-Tuning. And the process is actually surprisingly elegant. So first, the model generates an answer, like it always does. But then, instead of trying to learn from every single word, it looks at its own confidence score. It keeps the high-confidence words, that's the core logic, and it completely ignores the low-confidence ones. That's the stylistic noise. It's like a teacher telling you, hey, focus on the key arguments of this essay, not all the flowery language. And by doing this, the training becomes laser-focused on what actually matters, the logical skeleton of the answer. All that distracting, superficial style just gets tuned out. Of course, this is the big one, right? It's a really clever idea, but does this clever idea actually lead to better performance in the real world? Well, the researchers put ProFit head-to-head with the traditional method to find out. And the results are, well, they're pretty incredible. Let's just walk through this table. You've got the base model, with no fine-tuning, scoring around 41%. Now, look what happens with standard SFT. It barely makes a dent, inching up to just over 41%. But then, look at ProFit. The average score jumps to over 52%. That is not just a small bump, that is a massive leap in performance. To put that into perspective for you, that's a nearly 11% jump in accuracy over the standard method. In the world of AI development, getting that kind of improvement from a single new technique is, well, it's huge. It really shows a fundamental shift in how the model is learning.
And this comparison just drives the point home, doesn't it? You can see that clear gap between standard fine-tuning and ProFit. It's a consistent win, and it proves that teaching a model what to ignore is a way more robust and effective strategy.
So what are the bigger implications here? Why is this such a big deal for the future of how we develop AI? Well, ProFit delivers on 4 really key fronts. First, and most obviously, you get better performance. Second, it's more stable. It avoids that risk of accidentally making the model worse, which can happen with standard methods. Third, it creates a much stronger foundation for more advanced training down the line. And finally, it does all this efficiently, without needing these massive, expensive datasets.
Ultimately, the core lesson here is pretty profound. By intelligently teaching an AI what not to learn, what to filter out as just noise, we can actually help it focus on the signal. And that unlocks a much more powerful and efficient way to align it with what we want it to do.
And that leaves us with a really fascinating question to ponder. We've just shown that AI can learn to filter out the noise in human language to find the real signal. So, what other kinds of noise could we teach it to ignore? What new frontiers of intelligence could we unlock by teaching our AI not just what to learn, but what to leave behind?